Hello guys, we are back with another Leetcode problem. Today is day 11 of the Leetcode. Let's try to solve today's problem. So today's problem is sum of root to leaf binary numbers. Okay, so it's a highly like question. So let's read out what the question actually asks. You have given a root of binary tree and where each node has value 0 or 1. Each node root to leaf path represent a binary number starting with the most significant bit. For example, if the path is 0 1 1 0 1, then this could be represent 0 1 1 0 1 in a binary which is a 13. Okay. For all leaves in the tree, consider the numbers represented by the path from the root to leaf. Return the sum of this number. So So let's go with the example one, and I'm trying to explain what's actually this question asked. So in that case, you have given a binary tree. You have given a binary tree, and from this from root is the most significant bit, and the leaves are the least significant bits in a binary string. So in that case, if we go with that part one, then zero, that represent. I'll just type it here. If I go 1 to 0 to 0, it kind of represent it equal to 100, and this 100 means 4. Did you understand? If I go with 101, it represent 101, and 101 in the decimal form represent 3. And similarly 110, it represent 110, and corresponding this 110 binary string having the value what 6, and this 111 this represent triple one, and triple one having a corresponding value of decimal number is 7. So what we do, we just edit all the numbers and find out its summation. So that's kind of problem. So how can we do approach? So if I give you this string 1 100, so 1011, let's say 1 if I give this string, how could you do the manipulation? You come to this. If I do in the easy, if it's the problem of simple binary string, so what you do, you just iterate from here and multiply this number. You make sure one variable, let's say ans. In the ans you initialize with 0 initially, and after that what you do, you just make this some manipulation. You just multiply with the, because it's a binary, so that's why I'll just multiply with 2. So after that you just write it the si value, si minus 0 value. What you do, you just simply every time when you iterating, you just enhancing your ans variable by 2, and uh, multiply by 2, as well as you added the corresponding bit. Initially it's having the ans value 0, so it means when you add this thing, your ans into 2, it's 2, and when you add this, so your ans comes to the 1. After when you encounter this value 0, let's remove this. When you encounter this, so what you get when you encounter this, you will, your answer is equal to 1, 1 into 2, your, and here is 0, so 2 plus 0 is equal to 2, so your answer contain the value 2. If you reach to this index, it index having value 1, so here it's 1, but ans into 2, ans having the value 2 and to do 4, 4 plus 5, so your ans will be contain the value of 5. After that, when you iterate into here, so your ans having the value, your ans having the value 5, 5 into 2 10, and this having the value 1, so you your ans will be 11 in that case. So that's the approach. If I got this string, I can easily find out my ans summation corresponding value of this. And if I have a lots of string, so I find out all corresponding string decimal values, and after that I'll edit everyone. So how could I approach this? So it's a tree problem, and every tree problem having the recursion solution, and recursion solution we don't need to do by own or manually. Recursion do itself. We have only call this recursion very wisely. So today I'm going to teach you how can you call recursion wisely as your on this. So I'll just make it my answer in which store the all resultant value, means it's my answer which I'm going to return it from here. After doing some manipulation, my answer will be going to return, as well as first I mean it's like my answer equal to 0, because here I didn't, because my answer will be starting from 0. I just mentioned it in the below. So and I have make a function which do for me and do the computation, so I name it is a root solve, and it's containing a one parameter in which it store the values of the corresponding, means let's say if we travel from 100, it's going to store the path corresponding string value in the decimal number. So initially it having the 0, but after the computation it having some value, and that some value I'm going to add it my answer variable. So that's why I just taking initially 0. So let's try to make our solve function, and the solve function is a void function. So I'll make it, sorry, like one thing now. I just made a void function. It's and it's containing two parameters, tree node star, and let's name it root, and int data, which having the data. Okay, if my root having the value 0, means if it doesn't have any value, if root is null, it's my base case when I didn't want to compute anything. So here I just return it from here. Okay, and I call it solve. I'll just do one thing. I'll just compute. When I reaches here, I call it my left. I call it my left. Okay, as well as whenever I call it left, I'll just add it data having the value 0 initially, and I'll just multiply with 2. Same thing I'm going to do it, and I'm just adding this corresponding value, and the corresponding value is root val in that scenario. So it's going to be added. So it doing the computation, how can I do it? It's adding this value and just call it here, then again it's call it here, call it again, and it call it here. So I'm doing the computation on the one stage and calling my root solve function go and do the computation, as well as I have to call it write to. So I just call it root write, and having the data, I'm again calling data into 2 plus root val. So doing the computation same but in different area, means one is going to compute it here, so another going to compute here, or maybe it here, as like that. So everyone having the different values, and every whenever it reaches to root leaf, and this function not going to be stop because it's stop on the root is equal to null, and in that scenario it's going to return here is a null null, because it leaf node having node not having any what uh, root nodes, so that's going to stop 8 times because there's a 4, so every 4 having the two null nodes, child, so that's why it's going to return, it's going to stop at 8 times, but I have to stop here, so that's why I'll made it one more condition. If my root having some values, okay, but my root left will be null and my root right will be null. In that case, if my both root left and root right null, in that scenario it's my root node, so I have to add it into my answer. I have to add it into my answer, but I add it in my answer, but here I have to do the computation. If I'm here, I just do the computation. I'm calling here, I'm doing I done my computation till here, but not here. If I commit here, I have to, I didn't do the computation here because when I going here, then I'm doing the computation of here. So that's why I am adding the same thing here too, because I have to do manually thing. One more thing in manually, that's the thing. So I'm just going to add this val to here, and after adding this val here, after adding this val here, I have to return. So Ans Avenue, let's check it out guys, it's kind of work and there's no any cases left. Let's run this code guys, and it's kind of work or not. So I just, it's accepted. Let's submit our code and see. Hmm, that's a guy, yeah guys, it's accepted. So if you have any doubt, let me know in the comment section. I'm sure help you very soon. So take care, bye bye.